Hello and welcome to Chapter 5, Practice Problems here, and we're going to get going right away and start off with this first page. It's going to be a couple of videos because it's just going to take longer and longer to get through them, so just be prepared. All the videos will be in 15-minute sections, and I'll do my best to space them out. So here we are in Chapter 5, and Chapter 5 talks a lot about probability. So the first two problems here are kind of like a really big overview, and then the next couple problems are a little bit more broken down. And this first one is not necessarily health related. It's just one that I like to use to kind of take a little bit of break from all the health questions, but there are plenty more. So here we have our first day back at Hogwarts, and we have Hogwarts houses. We have Gryffindor, Ravenclaw, Hufflepuff, and Slytherin. And we have the number of students in each of these houses along with our total. So question A asks, what is the probability of picking a Hufflepuff on this given day? So when we do our probability, well, we find out how many are in Hufflepuff, and we see that's 87. And there's 87 students out of 346 students. And so we divide this out, and we're going to get 0.2514, or 25.14%. So the probability of picking a Hufflepuff at random here would be about a quarter, 25%. And if there's 4 houses and there's 87, I mean, it kind of makes sense, right? If you had 4 houses, that means they're probably evenly distributed amongst each other. So this would kind of make sense. But that is how we find the probability. You take the number 87 divided by 346. That's how we're getting our probability for picking a Hufflepuff. The next part is, what is the probability of picking a Slytherin or Ravenclaw on this given day? So same thing, you can tackle this in 2 ways. So we're going to first tackle it the same way we did the first problem. First we're going to have Slytherin, which I'm going to denote as an S. So in the Slytherin house you have 77 Slytherins over 346, which is going to equal 0.2225. And then in Ravenclaw, denoted with an R here, you have 92. So 92 over 346, and that equals 0.2659. Since these, we can pick a Slytherin or Ravenclaw here, you can take these two percentages and add them up, and you get a value of 0.4884, or 48.84%. So that is the probability of picking a Slytherin or Ravenclaw on that given day. So that's one way you can tackle it. The other way you can tackle it, of course, is you could just add up the probabilities together, add up 77 plus 92, and you're going to get 169 over 346. But then if you did it this way, you'd still get 0.4884. And that is the 2 ways you can tackle this type of problem. So moving on, and then part 2 here, we have Dumbledore has a task for you in which you have 8 different spells to accomplish. A new wizard or witch performs these spells. The current estimated success rate is 76%. The following table illustrates the total number of possible successes for a student and his or her corresponding probabilities. So here we have, you have 8 different spells to accomplish, and the current estimated success rate is 76%. So what we have here is the probability of this student completing 0 correct spells, 1 correct spells, 2, 3, 4, 5, 6, 7, 8, and this is the probability at each of these being correct, right, for that particular number. So that is how this problem is set up. Part A is what is the expected number of successful spells for a wizard/witch. So anytime you see expected number, always think average. If you see what is the expected number of this or that, expected number is just another way to say what is the average. And if you look in our book, we have the way that we find averages. And our formula is mu is equal to the sum of x times the probability of x equal x, where we have mu, right? Mu being the average value, mu, or expected number. The expected number is the sum of x times the probability of x equal x. So the way we write this out is we're going to add up all of our x's times the probability of that occurring. So if you take, so for example, we have the probability of 0 occurring. We're going to multiply that by 0.001, which is the probability of 0 occurring. And then we're going to add that to the x of 1 spell being cast, times the probability of 1 spell being cast. And we do this for each one of these. So the probability at 2 times 2 cast being cast, 0.072. And we do this across every one, and we're just adding up our values. So 3, the probability of casting 3 spells, the probability of that is 0.103 plus 4 times 0.127 plus 5 times 0.173 plus 6 times 0.278. I'm going to move this down. 7, so this is added, plus 7 times 0.146 plus 8 times 0.08. So 0 times 0.0001 is 0, of course, and then 1 times 0.001 is 0.011. Do this through for all of these when you're multiplying them out. 144, 0.309, 0.508, 0.865, 1.668, 1.022, and 0.64. So remember, with these, we're having the sum, sigma, sum. So we're adding these all together, and when you add them all together, you get 5.167. And this is the average. This is the expected number of spells that we estimate that this particular wizard or witch is going to cast. So they'll just get over 5.16 spells successfully done. So I'm going to skip number B just for the moment, just to go to C, because they kind of tied together. So C is, how does this wizard or witch perform compared to the current success rate? Well, the current success rate, we said, was what, 76%. And this particular witch wizard, with the types of spells being cast, only got 5.167 spells actually cast out of the 8, right? So the average of this particular witch and wizard was 64.59%. So when we compare these two values here, we can see that the witch and wizard perform slightly below the current success rate. Let me write that out. Perform slightly below the current success rate. And we can see that by taking their average number of successes that we got over 8, and you get their current success rate compared to the average success rate, and that's how we can determine that. All right, and then part B, which will be the last part of the video. So we want to find what is the variance of the distribution. So in order to find variance here, our formula is sigma squared times the sum of x minus mu squared times the probability of x equaling x. And so this is a pretty big, long, fancy formula to find the variance out when we're dealing with probabilities, but it's fairly straightforward. So we know what our mu is. Mu is what we calculated in part A here. So our mu is 5.167. And then, so when you're looking at this formula, it's kind of just plugging in the numbers you already know. So x of 0, so x minus mu squared times the probability of 0 at that particular spell is 0.001, right? All that together, and then we're going to sum those all. So I'm going to do the first couple here just because I'm looking at the time and I don't think I'll have enough time to write all of them out. So I'll do the first 4 so you can see it. So next you're going to add the sum of x. So next one we're going to be on 1 minus mu, which is 5.167. That value squared times the probability of 1, which is 0.011. Plus the probability at 2 minus mu, which is 5.167 squared, times the probability at 2 is 0.072, plus 3 minus mu times the squared times the probability of the number of successes at 3, which is 0.103. And so when you do this, remember, follow your orders of operation. You're going to want to subtract, square, then multiply out. So for these values, you get 0.0267 plus 0.191 plus 0.7222 plus at 3 is 0.4837. And now remember, you still have to do this for 4, 5, 6, 7, and 8. You do this for each one. I'm going to let you know what the total values at those particular probabilities are, so you can check your work, and that way you'll have the information. But due to time constraints, due to YouTube, I won't be able to go into full detail on this one. 0.4905 and 8 is 0.6421. So the probabilities at each of, determine the variance at each one of these probabilities corresponds as the following. Once you have all those, you add them all up and you get the sum. When you sum them all up, I'm going to just put this here, so the sigma, the sum of all of these equal 2.9269. And that is the variance of this distribution. Okay, and so that, like I said, the first 2 problems kind of go over a really big overview snapshot of the chapter. As we move on to the next ones, we break it down a little bit more and do more health-related example problems. And so that's where we'll pick up in video number 2 with the blood types for each one. And I'll see you all in the next video.